All right, hello once again. This is Jeff Scott of Rankin Technical College. We've been talking databases, and I'm up to page 88 of our textbook, the one that we've been using for this, SQL, A Beginner's Guide. We are in the middle of Chapter 4, and they are now talking about the match clause. And it says it's not supported by MySQL 5.0, and I still think that even in later versions it's not. You'll notice here it says, as an aside, MySQL 5.6 supports full text searches on InnoDB tables. All right. And I'm not sure if it actually supports the match clause or not. I've never ever used it. I've never seen it used in a MySQL book, but we will talk about full text searches later on. So I'm just going to skip that for now on, or from now, I mean. The referential triggered action clause. All right, it says this allows you to define what types of actions should be taken when attempting to update or delete data from reference columns. All right. The point to remember about this is that you are including in the definition of the referencing table an action that should be taken. Let's quickly take a look at these. All right. Before I even go through the little diatribe that's down here, the little talk, let's talk about in English what's happening. Notice there's an on delete and there's an on update. All right. We're talking here about referential integrity, so we're talking about child records and we are talking about parent records. All right. When you've got an on delete, what that says is if you remove or delete the parent, automatically delete any child records. The on update says if you update the parent record, immediately update the child records. So this has to do with cascading. So typically you're talking about a situation where you have a primary key in a parent table that is being somehow it is being removed or altered or whatever. And how are you going to have the child table react to this? All right, the author says here, if cascade is used and data is updated or deleted, then the data in the child or referencing columns will automatically be updated or deleted. All right. If set null is used, the value in the child columns will be set to null. If set default is used, the values in the corresponding referencing columns will be set to any default values. If you use restrict, it says if you use restrict and you try to update or delete the reference columns, it would cause a foreign key violation. You just kept from doing it. Finally, there's no action. As it says, if you use that and you try to update or delete basically something that would cause a foreign key violation, you are again prevented from doing the application. So you'll oftentimes see stuff like this, on update cascade, on delete cascade. And again, what both of those mean is for the update, when they say cascade, what they're saying is any change you make to the parent, cascade it down and make it also work to the child. All right, adding not null, unique, and referential constraints. If you add not null, which I believe is the default anyway, but if you add that to a field name, What that means is that particular field name is not allowed, it is not allowed to have null values. In other words, you can't leave it blank. Kind of an interesting picture here. This is the data model for their inventory, CD inventory database. And what can you tell from this? Well, you'll notice here that you've got a table that's called artist CDs. All right? And it says that the artist ID is a foreign key into the artist table. The compact CD or compact disc ID is a foreign key into the compact discs table. Again, if you look at the artist table and you look at the compact disc table, you'll notice they have no fields in common. But by creating one of these, what's referred to as junction tables, which takes the primary key from one table, the primary key from another table, and it puts them into their own table as a concatenated primary key. Now, using the artist CDs table, we are able to directly relate the artist and the compact CDs table. And there are some other foreign key examples on here also. The compact disc type looks like it's kind of used the same way. It has the primary key from the compact discs table, the compact disc ID, and the primary key from the music type table, which is the music type ID, and those are its only fields. But they're in there so they are able, now we can directly relate the compact disc or compact disc table to the music type table based on, or doing it through this compact disc types table. Now again, this is a data model, and the author is showing you one way to create a data model. I believe I mentioned this to you before, but I would strongly suggest that you go out to udemy.com, udemy.com, and you search for a course in there that's using MySQL. I think it's database design using MySQL. And it's a free course taught by Brad Traversy of Eduonics Learning Solutions. He goes through a lot of this stuff in much more breadth and depth of coverage, and actually goes through his own 6-step design process. I don't normally do this, but I'm going to click on this, and I'm going to come and find, I've been reviewing it, rewatching it, planning and design. And he goes through here his own database design process. I'm going to cut his sound off, and I'm going to come in here and see if I can find the area where he gives his 6-step process, because it's done pretty well. Oh, I think it must be right in here someplace. So step 1 is to define your purpose, the purpose of the database and the applications that will use it. Step 2, you determine your tables. Once you figure out the purpose and what kinds of tasks you need to perform, you can divide the information up into tables. You should follow a naming convention, regardless of what it is. You know, it might be that you work for a company that already has their own convention. Step 3, determine your fields. So now you've determined your tables. Now you want to determine what fields should be in each of those tables. Step 4, determine your relationships. How are those tables going to be related to one another? Must those tables be related to one another? And if so, and there's no current way to relate them, you might have to create one of those junction or join tables to handle that situation. Step 5, all right, use something like MySQL Workbench to create a diagram editor. I hope to be able to show you that later because you can also do that via phpMyAdmin. Then finally, step 6, go through. It says in step 5, you want to take a step back and really look at the data structure and make any decisions or changes needed. Don't worry if you forgot something or made any errors. This is like a rough draft. You can always improve upon it as time goes on. And what he's showing in there is just one way of doing this. Again, I'm not going to say it's the best way or it's not the best way, but it looks to be a fairly good way of doing things. So there's a step-by-step where you do something similar to that in here. I'm not going to go through it. I'm not going through any of these step-by-steps. All right. The next thing that's in here, and it's on page 95, is they talk about what's referred to as a check constraint. And as mentioned, you can see it on the screen here, a check constraint allows you to specify what values can be included in a column. They're the most flexible of constraints and they're the most complicated. So the basic structure is shown right here. But again, let's take a look at an example. This is saying you've got a field called in stock. And the in stock must be between 0 and 30. So, greater than 0. So, starting with 1, less than 30. So 1 through 29. And they mention right underneath it, if you were try to enter a value into in stock, which is either 0 or less, or 30 or more, you receive an error. And there are a lot of different ways that you can do this. Think about what you might want to do. This isn't the greatest of examples, but what if you could write a really complex check that checked the month number. And if the month number was 1 for January, or 3 for March, or 5 for May, or 7 for July, or 8 for August, or 10 for October, or 12 for December, any one of those 7 months, then you'd want to set month days to 31. All right. If the value in there was April or June or September or November, if it was any of those 4 months, you'd want to set the max value for months to 30. And if it was February, you'd have to check to see whether or not it was a leap year. If it was not a leap year, the maximum days of the month would be 28. If it was a leap year, the maximum days of the month would be 29. So you can write really complex checks if you need to or have to. And if you say, well, this almost looks like programming, because it is pretty darn close to programming. All right? And I believe the last thing that's discussed in the chapter are assertions. And as they mentioned, an assertion is merely a type of check constraint that can be applied to multiple tables. Another one I have not really used very well. It says creating an assertion is very similar to creating a table check constraint. After the check keyword, you must provide the necessary search conditions. It says, let's look at an example. Suppose the CD titles table contains a column for the number of compact discs or CDs in stock. You want the total to always be less than the maximum inventory that you carry. So in this example, the author has created an assertion that totals the values in the in-stock column, and it verifies that that total is less than 5,000. Now they're using what's called a subquery in here, and we'll get to that in a later chapter. So they mentioned if you try to add a value to an in-stock column that would cause the total, when you add them up, to exceed 5,000, you get an error. All right, I mentioned a long time ago we talked about domains, and I just gave you some examples. A month domain might be between 1 and 31, or 1 and 30, or 1 and 29, or 1 and 28. Those are domains. You can set up domains, and here's an example where they set one up. So they say that the in-stock value must be between 0 and 30. It says the only really new item here other than the create domain clause, is the keyword value, which refers to the value of the column, in this case, defined within the stock amount domain. So if you were to try to enter a value less than 0 or greater than 30, you'd receive an error. And again, they have another exercise on this on page 99. Now that pretty much finishes up this chapter as far as I can tell. So in this chapter, what did we do? Well, we came in and we talked a lot about different kinds of constraints. In the next chapter, chapter 5, which I'm going to go over, but it's going to be one lecture, I know only, not two, and it'll be fairly brief, and it's on creating SQL views. And all a view is it's a saved query. If you write queries, especially that are long and or complex, and they're very error prone, you want to write that once, get your results as expected, and then save the query as a view. So I'll be back with that shortly.